One, two, three, testing, testing. Okay. Welcome back to your regularly scheduled programming. I am John Schultz, and tonight we're going to be working on lists. As a quick review of what we did last time, we worked on variables. As we can see on the screen right now, what we have are two different variables that represent the number 1 million. To make it easier for humans to read, we can add this underscore here that we see on our screen, and the computer will read that as just 1 million. So that's one of the things we went over. So we talked about different types of data or data types. We talked about strings, which are represented either in single or double quotes. Oh, look at me putting name. Ha. My name is John. We talked about ints or integers. I think I'm 35, something like that. And then we talked a little bit about floats, which is a decimal point representation of our numbers. So I know we used height, but that's a bad one. So we're just going to use, I don't know, x, because I'm drawing a blank here. X is equal to 3 point, or no, pi. Goofy me. Pi is equal to 3.14. And you can perform mathematical operations with these numbers. If you add an int to a float, the resulting number is going to be a float. The same thing as far as multiplication and division. It's going to go to whatever the greatest level of precision will be. So if that makes sense, if you multiply 2 times 2.5, you're going to get 5.0. We'll actually do a representation of that here. 2.5. And then we're going to print age times pi, which is so wrong as far as the actual my age times pi is equal to 5. So we'll see it. But it's the form that I'd like us to see. And I still am doing messing up here. There we go. We can see that it's 5.0. So even though it's a round number as a whole integer, which is an integer is a whole number, positive or negative, the floating points, which is why they're called floats, results in 5.0. The same thing were to happen if we were to reverse that, or not reverse it, if we were to divide 5 by 2, so we're doing age divided by pi now. We're going to execute. And it gives us 2.5, which is what we're expecting. Now something else that's kind of neat to watch is what if we divide it as a whole number? So we know that there's no remainder when it comes to 4 divided by 2, so we're going to show that. We're going to show what data type it comes back as. And again, it goes to the greatest level of precision, 2.0. Even though intuitively, if you divide 4 by 2, you get a whole number or an integer, this still is represented by a floating point. So that was quick review. I'm going to leave this on the screen for those that are typing. And tonight we're going to begin working with lists. Let's see here. We are using the Python book. So a list is exactly what it sounds like. If you think about like a grocery list, you have different items on the list. They may be related to each other. If you're trying to put together a recipe, they may not be related. They might just be things that you need in the store that might not necessarily be food. So when my wife creates a grocery list, normally she tries to group all the cold stuff together and then all the snacks for the kids. But then if we need light bulbs or toilet paper, those are not technically groceries, but we can get them from the store. They're on the list. And if they're not on the list, then I'm not buying them because I will forget. Because I'm trying not to be that husband that calls her, hey, they're out of the blue label ones. I need the. Anyways, that's a joke just for me. So a list looks like this. We have a label for the list. Think of it like a container. we're going to say we're going to say books. So the framework, or I guess the symbol that we use to represent a list are these things called square brackets. I don't think I can zoom in anymore. Oh, look, yes we can. How about that? Square brackets. The reason why we specify square brackets is because there's a thing called a curly bracket. Some people call them curly braces. That does something else. We'll review that when we get to it. And inside the square brackets, you can have many different items. You can have one item, you can have no items, you can have a billion items, just however many your memory allows you to, more than you want. They can hold various different data types inside the list. So I want, let's see here, Moby Dick, that's the name of a book, comma, and then what's another one here? From my in-person people. Green eggs and ham. Classic, comma, space. The space is for humans to read it easy. You don't have to put them in there, but it's really good to have good practice. And then we'll do one more book. We'll do the Bible, because it's technically a book. Notice how each one of these strings, which is what they are separated by a comma inside the square brackets. That tells the computer where the separation of the individual items are. If we didn't have the comma there, it would be confused. It would think, why are there two closing parentheses? No. Quote, quotes, double quote. Goodness, my brain is fried today. We can also do other things. Besides strings, we can also add in integers. 1, 2, 3. We can do floats, 1.7 something, whatever. And they don't necessarily have to be of the same data type in order to get access. That's the point here. Actually, we'll go bonkers and we'll put a negative there. How about that? So to make it a little more viewable, to review, we have a list. Notice this is really cool, just something that Visual Studios allows. So we have a variable, and this shows me that it's a variable. The name of it is books, and the type is a list. So it's really handy. Now that we have our list, we can do things with it. One of my favorite things to do is to print. If we print the books, what it's going to do is it's going to show us a visual representation of what this list looks like as a data type. I keep moving into the wrong space. And it looks just like our code, the actual list itself. It's kind of neat to look at the first time, but it's not super useful if we want to do anything meaningful with it. We've got to be able to identify which element in the list that we're referring to, or which item in the list that we're taking care of. The different things inside the list oftentimes are called elements. So what we do is we got another square bracket, and we specify inside that square bracket which one we're wanting to represent. Now in computer science, in most programming languages, lists, arrays, all of these start not with the number 1. I'm getting ahead of myself. I was going to show you first and then explain. No, give it to me. There we go. So we called books number 1. The number 1 position in the books list is another way that you can think about it. And it gave us the second item in that list. The reason is because these lists, they start with 0. You can call it index 0 or position 0, but they start at 0. So if I really wanted the first one in the list, I would put a 0 here, and then I would re-execute it, and then it is going to show the book that we were trying to target. We'll be there. Any questions from the class so far? Go ahead.
How can you list multiple? Just put a comma, like 0, comma 1?
Are you talking about
Yes.
like printing out multiple things? It's a great question. It really depends on how many you're trying to do. With lists, there's a thing called start, stop, step. Write that down. Start, stop, step. They have default values. The start is going to be whatever you put in the brackets. If it doesn't have anything inside that bracket, it's just going to give you the whole thing. If it's stop, then it's going to include the elements that you've arranged. And we're going to look at that right now and see what that looks like. So we're going to start at 0, and we're going to stop at number, we'll say 2. And this is kind of neat too. You see how when I started typing in here, it gives me a little bit more information on that particular functionality. This looks crazy confusing, so I would recommend not looking at it too much. But if we can see here, it's a values, it's an object, step, string, none, end. So yeah, I wouldn't recommend going into it too much. Edit that out. So I'm going to execute the code. And we got a bug. It didn't like it. List indices must be integers or slices, not tuples. Where did we go wrong? Ah. So we're going to stop the code. And it's not with comments, it's actually with colons. 2 dots. Start, stop. And if I have another colon, that would be the step. And we'll represent that here in just a minute. So we're going to execute. What do you think is going to happen actually? Just looking at it here, if it's starting at 0 and stopping at 2, what do you think is actually going to print to the screen? So that's 0, 1, and 2. Let's see. Going down. Oops. Stop it. No. Okay. I must have clicked something. Here we go. Here we go. It actually just gives us the first 2 whole elements because it stopped at position 2. It did not include position 2 or index 2, if you will. Oops. There we go. If we wanted to include the second, index 2, we would go to 3. So starting at 0, including 0, and stopping at whatever element it is. Now, if we wanted to do start, stop, and step, we would do the first element. We're going to stop at, let's say, position 4. And we're going to step as 2. It defaults to 1. So 0, 4, and 2. What I predict is it's going to give us every other element in the array from, I'm sorry, in the list from 0 to 4. Come on. Really got to figure out how to get that to pop up on the right screen. It gave us the first book, the first float, and then it stopped after that. 0, 1, 2, 3, 4. But remember, we stop at 4. We did not include 4. So if we wanted to include 4, we would have to go to the end. So that's one of the ways that we can do different groups of elements on the screen. Another kind of a fun Python-y thing that you can do is you can actually go negative numbers. And a negative index doesn't make a whole lot of sense, but what it does is it actually grabs whatever's at the end of the list and works backwards. So if I print books -1, it's going to give me the Bible, as we can see here. It is the last element in the array. I keep calling it an array because that's a different data type in another language. This is list, Python list. So if I were to put a -2 here, it would give us green eggs and ham. -3, it would give us the float. -4. What do you think will happen if I put in like a -7? It would, absolutely. Because there's no index that's that far back. There's not enough elements in the list. The index is out of range. I also want to point out that when we did that for the first time, so I'm going to put the little X. There we go. We didn't have -0, right? That's nonsensical. If you're grabbing elements from the back of the list, it always starts with -1. So again, moving forward from the start of the list, we start at element 0. But if you're grabbing from the end, you're going from -1, -2, -3, and so on. So now I'm going to show you -1, and then let's see here, we're going to stop at 1. I'm not sure what's going to happen. It gives me a blank. Oh, we stopped at 0. Let me go with 5. No. 4. Combining multiple things together. I don't like it. Now you can do other things with this particular functionality as well. Let's say we're going to get books 0. All of the functions that we talked about last time that apply to strings, we can apply them here as well to elements of a list. We know that the first element is a string, so we can go dot upper, open and close parentheses, and it should, print out the first book in all capital letters. And what we did to that was it took that element and it added that dot upper functionality to it that we were working with last time. Same thing with dot lower, dot title, that kind of thing. How are we so far?
Is there one for italicized?
Oh, no, that's a styling. Okay. Oh, it did. Huzzah. So, some other things that we can do with lists. We can add things to them. What good is a list if we can't even add things to it? When adding things to a list, we're going to keep the -1. I say keep it, it's not even there. When we print, we're still going to print the last thing that's in the list. And the reason is because we're going to say, what's another book? Say book 4 is equal to, no, that's not necessary. I'm going to say books dot append. Oh, this is really cool. So notice what happens on the screen. So I have books, and then when I put a dot, it gives me a bunch of built-in functionality that you can do to a list. Count, extend, pop, insert. These are really cool. We're going to go through some of them tonight. The first one we're going to do is append. So books.append, open and close parentheses. Remember from last time that the open and close parentheses show that it's a like a function. Inside the function is going to be an argument. So we have to tell it what we're going to append to it. We're going to say Python textbook. And then we're going to print two things. We're going to print the actual list again. And we knew from our test earlier that by just putting the variable name inside the print gives us the whole thing. And then we're going to print just the last element. So it's going to do that really quickly. There we go. So we started with the original list here. I just realized I don't have numbers on here. I'll have to fix that. Having numbered lines of code are helpful when you're looking to try and debug and coach. So we print out the whole list. We started with a list, books, and then we appended or added to the end that Python textbook right at the end. And then with our next function, we printed the first list, the newly appended list, if you will, which includes all of the elements, and then we grabbed or we printed the last one, the -1 value of that list, the newly appended Python textbook. Make sense? So that's appending. We can do some other things. We can actually do something called insert. So let's say that we want to, now we'll insert later. Let's say we want to change the first book. If we want to change the first book, we're going to do books, open and close square brackets. Remember, it's at position 0 is the first element. So we're going to make that equal to another string. We'll call it Django, D-J-A-N-G-O textbook. Django is a framework that's inside Python. I'm going to copy my print statement so we can look at what it prints out before, and then we're going to look at what it prints out after. Okay. There we go. Okay, so what it does is it prints out, we have the first time we see the books variable, we call that an initialization. We initialize that variable, books, as a list comprised of all the individual elements. Then we print that to the screen. That gives us this first list here. Then we append that list with that Python textbook right at the end. And then we also change the first element. We give it a new value. Just like we changed name in our previous lesson to my name or your name or ages like we did in the homework, we can change the individual element, the data that lives in that first slot, to whatever we want. So we specify where we want to put our new data. That's going to be in books position 0, or that first element. We're going to change that name to Django textbook, and then we print out the whole list again. We see here in the second line that Moby Dick is now changed to Django textbook. And so the destruction of classical literature begins. And then finally we print out the Python textbook because it's still at the end and we didn't change that functionality. But we can see how the data is transformed as we go through the code. From books, print books, we appended, we changed, and then we printed it out again. We can also walk through this step by step as we hit F10 and F11 on your keyboard as you're going through the debugging phase. We can set it as I don't know if we remember our breakpoints from last time. It's a really good time to review. So as you have your mouse over here on the left, as soon as it changes directions, you're able to touch and make a little red circle. Then when you execute the code, it will go until that point and not include that point until you hit another button. It gives us our watch variables, which is kind of neat. Now down here, we only talked about watch last time. I don't know what that first one says. We talked about watch, about how we can add individual elements to that list. But there's another tab here called locals. These are all of the variables that we've included up until that point. So if we scroll up, we still have number 1, 2, name, age, pi, right? We've got all of these things. Name, number 1, number 2, that million that we did earlier, pi is 2, which is wrong mathematically, but don't hate me for it. This music stand keeps sliding. Okay. And then as we begin to step through our code, these are our symbols over here. Step over, step into, F10. Now we see that the little yellow arrow moves to the next line. We should have a message printed to the screen because that's the line that was just executed where it printed that books. That's where our breakpoint stops. We went over to the next line of code. Now we're at the appending. We notice that none of our data types have changed yet. Where's our books variable? Here it is. It's still Moby Dick as of this point. So we hit F11. There we go. We notice how it moved to the next one and about how now down here we see where it's red. That indicates that it's changed or updated. And we can see how that is now appended. It's a little longer. The Python textbook. And if I hit continue, it just goes until it finds another stop point, which it won't, or break point, sorry. I'm going to remove it just for fun. Any questions so far as manipulating lists? We can append things to it. We can call different positions based on the index or the well, that's really what it's called. Whatever number it is in line, starting with 0. So we've learned how to add things to the list. Now we're going to take things away. And depending on where it's at, we're going to take things away. So we're going to go with books, dot, and again, it gives us this really cool list. We're going to go with pop. Books.pop. Actually, before we do books.pop, I'm just going to comment that out real quick. It's always best to comment out working code instead of deleting it altogether. This is a pro tip. Please do it in case you need it later. So there is a way that we can actually add things to the list without having to write it over. Like if we wanted to add something in the middle of a list. Here it is. And that is going to be the name of the list. So we're going to do books, dot, and it's going to be insert. I had to use my textbook to make sure I was right. Now inside that parentheses, again, the parentheses represent a function of that data type or variable. So we're going to insert. Now we have to tell it what we want to insert. We're going to have another book. We're going to say C++ text. That's another programming language. And then we're going to separate it with a comma. If you're ever curious as to what you need, insert object before index. Okay. And now we have to tell it at what position in the list that we would like it to be. So we have our text or our data type. It could be numbers, it could be floats, it could be strings. We have a comma and then a space, and I want to put this right in the middle. So let's say, how do we find the middle? Now, one thing at a time. We're just going to put it at position 3, index 3. So remembering our index starts with 0, 0, 1, 2, 3. It should go right here. And then green eggs and ham and the Bible are going to get pushed out. Of course, we're going to have our Python and our Django, and we're going to, I'm going to take this print statement and I'm going to move it down here. We're just going to run it. We're going to see where the C++ textbook is located. I almost got ahead of myself. No, we're not. String object cannot be interpreted as an integer. Did I get them backwards? I did. I got it backwards.
Took a number first.
The number of where it needs to go first, and then what you're putting. Thankfully, we have some error codes that help keep us straight. So we're going to try again. Ta-da! So we have Django textbook, 1, 2, 3, 0, 1, 2, 3, 4, 5, 6. Oh, funny enough, it was right here in the middle. We're going to keep going. Now, what if instead, we know we want to put it in the middle, but let's say we don't know how long the list is. A lot of times you'll end up using data that you don't have control over how long or short it is. So what we're going to do is we're going to find out how long the list is, and then we're going to divide that number by 2, and that will be the index, rounded to a whole number, of course, that we're going to put this C++ text into. We're going to do that by finding book.length. Oh, it is books. Thank you. Len. There we go. And we're going to divide that by 2 and hope that it doesn't give me an error. Here we go. It does. List object has no attribute of len. There we go. That's better. Okay. I'm going to put it up here, kind of in its own space so that we know what it looks like. So we're going to say the length is equal to len of books. Just to make this not quite as cluttered. So what this is doing is it's taking books, it's finding out how long it is. And by length, I'm talking how many elements are in it. It's saving that number to this variable here. I'm going to put a breakpoint here so that we can stop and analyze it as it runs. Syntax unmatched. 19. Ah. I accidentally left a parentheses out there in the middle of nowhere for no reason. And trying again. Actually trying again. Make sure to click the button. So we have here, we have length. We're going to type in length into our watch window. Now it's 6. But is that correct? 1, 2, 3, 4, 5, and then we appended one more item onto it. So it's a length of 6. Notice it's not a length of 5, even though the 5th element, fantastic movie, the 5th element would be Python textbook. but there are 6 actual items in the list at that point. Does that make sense? Because we started with the 5, and then we added the 6th. And then we changed the first one. But the total length is 6. So now it's going to pass that variable into this function here after it prints out again. I've got a lot of stuff going on here. I need to simplify it. It's going to divide that by 2. It's going to give us the index, and we're going to put that C++ textbook in there. So we're going to continue, and we get an exception. Integer expected got float. Why do you think that happened? Because from our demonstration earlier, we know that if you divide 2 numbers, it returns a float, even if it's evenly divisible. So we have to make sure that it gets turned to an integer afterwards. We can do that by typing int and surrounding it with these parentheses. I'm doing a whole lot to try and figure out where the middle of it is. Okay. I'm going to remove the breakpoint. So a lot of stuff going on here. I want to break it down. So with this books.insert, we're taking the length of the books that we got from here, which we know now to be 6. We're dividing that by 2. That's going to give us 3.0. Then we're taking that and we're putting it inside these parentheses. Come on. Stop it. Stop it. What's cool is when you highlight one of the parentheses, I could just use a mouse. It's all the way over there. That's an argument. It's going to take, int is going to take whatever's inside those parentheses and transform it into an integer or a whole number. That's going to give us 3 here, and it's going to put that C++ textbook, and then we're going to print it out. Make sense? I can do it again. Does it make sense? Okay. You had a look. If I'm going too quick, please let me know. I don't care about the recording. Y'all are more important because you're physically here. No offense, you should be in class. So when we execute it, it prints out our list again. Ta-da! C++ right in the middle of the length. Cool, huh? I really love this. Thank y'all so much for being here. So now we have learned how to create a list, which we've done here. We've appended things to the list. We've changed things in the list. By the way, this doesn't have to be Django textbook. It can be a string. It can be a float. It can be anything we want to replace it. It doesn't have to be the same thing. It's very malleable. When you say add things, and you're talking about like join green eggs and ham and the Bible. Mathematically, for sure. If we wanted to, let me comment this stuff out. This is kind of a fun keyboard trick. If you're wanting to highlight and comment out big sections of code, what you can do is you can highlight it with your mouse first. So I'm just going to do these here. There's a button up here that you can use. Let's see. Comment out the selected lines. I like to do it on the keyboard because it's a little bit faster. You hold down the control button with your pinky, and then you hit and let go of the letter K and then the letter C. And that will comment out the whole thing. It's the same, it shows you up here. And then to undo that, you have it highlighted, you hold down control, you tap the letter K and then U, and that uncomments out. Notice here on books.pop, when I hit comment it out, it adds an additional comment block to it. Doesn't remove both of them whenever I undo it. If I did it twice, it would. Make sense? So that's how you can comment out whole blocks of code if you're just doing some testing. Like I said, it's better to comment out blocks of code instead of deleting. That way you don't accidentally delete something you're not supposed to. Ruin production. The bank was down for 3 days. That's not necessarily true. I'm just kidding. I'm a little extra. Okay. My wife can't take me anywhere. But mathematically, we're wanting to add, let's say, let's turn the whole thing upside down. Let's do it. Let's say we're going to get rid of our books. I don't know why I'm doing that. I can just comment it out. If you're doing just one line, make sure you have a space just for readability. We're going to say numbers because the hardest part of being a DM is naming convention. And we have our square brackets, and we're just going to type in 1, comma, space 2, 3, 4, 5, 6, 7, 8, 9, 10. And if you've ever been a kid and ever been super bored, you understand that if you sum the digits of 1 to 10 together, you get 55. But we're going to prove it. We're going to prove it with actually the next cool thing in lists. We didn't talk about pop yet. Let's do pop first. Sorry. But we'll come right back to this, I promise. Before we go too far, I want to demonstrate these two things, books and numbers. Wow, we're really advanced in this class. Books and numbers, there's a little squiggly line. It's an error. Unindent, not expected. Unexpected indentation. With Python, the white space that's around your code actually matters because it's going to do everything in line. And the reason behind that is because of functions later on. You talked and asked earlier about the if statement and about how the second line, the print yes, was moved over. The reason is due to the fact that if that was true, it will do what's in the indentation, right? If it's not true, it's just going to keep moving past. So if we have extra space for no reason, your code's not going to run. It's going to yell at you. I say yell at you, the red squigglies. So now we're going to pop. As soon as we pop, we'll go into the next one. I promise. Oops. Stop it. I hit the wrong. Did I hit insert? Books. Books.pop. And then prints books. Oops. What pop is going to do is going to go to work. Oh, that was such a lame dad joke. It's going to pop off the last elements of the list. Now we know from earlier that the last element that we added onto the list would have been Python textbook, but instead I've committed the mortal sin and have gotten rid of the Bible. I'm so sorry, Jesus. Sorry. I didn't mean to get rid of the Bible. I will. Books.pop. I just had it scrolled up a little earlier, that's not the right word, a little bit ago, because I wanted to show the original list, had the Bible, and then we popped off the last elements in that list. We can also pop off specific spots in the list. It defaults to the last item in the list, or -1, if you will. But if we wanted to get rid of the first element, not -1, that's the same thing we just did. So if we wanted to pop off the first one, pop off king, right? That's something the new people say. We're going to pop off the first one. But are we going to pop off the first one? No, we popped off position 1. We did not pop off 0. We popped off the 1, 2, 3, the integer that we had. Coding is so cool because I accidentally do all this stuff and it reinforces the fact that you have got to be careful with whatever you type. Computers are amazing in the fact that they'll do exactly what you say. But they're bad because they'll do exactly what you say. I didn't mean to actually get rid of the integer. I meant to get rid of this first book. But it did exactly what I said. Okay, first element. Not element 0, element 1. You got it. It's gone. So make sure to always double check what you're actually getting rid of, especially if you work at a bank. I'm sorry. No actual banks were harmed in the making of this tutorial. What time is it?
Almost 8.
Oh my gosh. All right, we're going to do the addition thing, and then we will wrap up for the evening. So you were talking about adding different. Any question on pop?
On pop, can you use start, step, and stop just like you do with print?
I've never actually tried that. You're welcome to try it and see what happens. Just not right this second. So we're still going to print out, instead of books, we're going to print out result. Now we don't have a variable result, which is why it gives us the green line. It's like, what are you talking about? It's not here. Result is not defined. So we're going to define it. Result is equal to, let's see, what's the best way to do this? Really, it's the best way to do it is to loop through. My old C++ teacher, Dr. Rachel, you're the best, in case you're saying this, I love you, man. He would say for loops and arrays, or in this case, lists, they go together like peas and carrots, man. Peas and carrots, loops and lists. So this is a for loop. And we're going to say for each item in numbers, colon, we're going to say the result, we're going to start up here as result is equal to 0. Result is going to be equal to that each plus the result. I'm going to put a little bit of white space around here so that we can kind of go through what is actually going to happen. The each is an integer value that starts at 0, and then for each element in the numbers list, starting with position 0, 1, 2, it would be more helpful, I think, if I actually put a 0 in here. Okay, starting with 0, and then going to 1, and then going to 2, going to 3. So every time it encounters a new position in the list, it's going to take whatever that value is, and it's going to put it here. It's going to add that value to the result, which started at 0, and then it's going to increase it as it goes through the list. And then, at the end, we're going to print that result to the screen. Except we're not going to do it there because we'll get an indentation unexpected. That's something else that's handy. If you want to unindent, you can hit Shift and Tab, and it will take away an indentation, just for fun. I'm going to print it first. I say print. Look at me doing this in the middle of executing code. What is wrong with me? Okay. So I'm going to print, or start. It's going to run through the whole thing, and it's going to give us the number. And I spoiled it earlier when I said that the total is going to be 55. But now, while we still have 2 minutes, I'm going to put a breakpoint here. And we're going to step through this, and you're going to see how it adds each one to itself. This is so cool. So lists and for loops go together like peas and carrots. So there's nothing really to display at this point because it hasn't initialized it yet. So I'm just going to step through to the next one. Here we go. Let me use our viewing window down here. It's looking for length. What is length? We don't know. We're going to put each. We're going to put numbers. And then we're going to put result. What's cool is that we're able to see as each one. So each, again, started at 0. We have our numbers array that we established here, and then we have our results, which was initialized right underneath numbers. I got to put the line numbers here. So now we're going to step through it. It goes back up. The first number was 0. It's going to change each. Now each is at position 1, index 1. It's going to grab the value from index. It's going to add it to the result. Now it's going to grab the next one. result. Now 6, 10. It just so happens that our index and the number that it's adding happens to be the same. We're going to adjust for that here in a little bit. 21. As we can see, it's going back and forth. Notice how it hasn't gone below that because there's still more that it's expecting. Each is looking for every element, and it's not going to stop until it finds the end. This is where it finds the end. The end was value 10, which happened to be index 10. So then it goes to the next one, prints the result, and that's where we get our magic 55. I want to do one more thing. I'm going to add a factor of 10, I don't know if that's the right word, to each of these. Now mathematically, we should get 550, right? But I want to step through each one. There we go. So we start at 0. 0. Now each is now identifying number 10. Watch this. So I click continue, it goes back to that breakpoint because that's where we put the breakpoint. I click continue, it does the next step. It shows us which has changed since the last time it was there. Come on, continue. It's just a little bit slower than stepping through, where we can see one change at a time. Just a little bit faster. And then it prints 550 to our screen. Huzzah. Now we have our numbers array, we have our loop, and then we did something with each loop. So the homework for tonight, we're good for this week. Your homework will be to create a list we'll just say of numbers. They can be integers, they can be floats, as long as they're numeric in nature. And it has to be at least, we'll say 15 long. It has to be a length of 15. Okay. What I would like you to do is demonstrate that we can pop off the middle one. So then it reduces it down to size of 14, right? We're going to insert the number 300 into the middle. And then we're going to loop through that. I would like too complex. Multiplying is too big. We're going to add, we'll just add them up. No reason to go bonkers. When we go through conditional logic next week, we're going to add the first one and then subtract the second one, and then add and subtract and add and subtract. You can see if you can figure it out on your own, how to add the first one that it comes up with and then subtract the next one. Add and subtract, add and subtract. There's a way to do it. But if you get this point done, it'll show that you have an understanding of how lists work. You can push and pop, play with it, have some fun. But that is going to be all for your regular scheduled programming.